Okay, so let's do another problem. So the last one we had to find the equilibrium concentrations, then we plugged it in to find Kc. This problem is going to be kind of the flip. We have Kc and we're trying to find the equilibrium concentrations, okay? So let's look at how to approach this problem. So it says H2 plus I2 reacts to form two HIs. I have 0.05 moles of HI is placed in an empty 1 liter flask at 600 Kelvin. What will be HI's concentration, H2 concentration, and I2 concentration at equilibrium? Kc is 76 at 600 K. All right, so same process as always. What am I looking for? What's my question mark? So what I'm looking for is I'm looking for those equilibrium concentrations. So I want to know what is HI at equilibrium, H2 at equilibrium, and I2 at equilibrium. Okay, so I want to know what those equilibrium concentrations are. All right, what did they give me? So they said for HI that it was 0.05 moles, okay. They said that the volume was a 1 liter flask. My temperature is 600 K, and my Kc is 76. All right, so I got HI, volume, temperature, and my Kc. So I need to find the equilibrium concentrations. If you're told that you have to find the equilibrium concentrations, you automatically need to go to an ice table, okay? Because the way that we're gonna find these is kind of the same way we did last time with the X, but how we solve for X is gonna be different. So we'll still have X, but instead of using, like in this problem where we used this equilibrium right here, so instead of using one of the given equilibrium concentrations to solve for X, and this time we're gonna end up using Kc, okay? So, when in doubt, honestly, in these problems in the back part of this chapter, when in doubt, use an ice table, okay? But you don't always have to use the ice table. Sometimes it's easier, like the stuff that we did in the beginning, where it's just plug it in and solve. All right, so let's do an ice table. H2 gas plus I2 gas goes to 2HI gas. Initial change equilibrium. All right, so what do I know initially? So the only thing I know about initially is my HI, but it's in moles, and I need them to be in concentrations. When I plug this stuff in, it needs to be concentrations. Sorry, excuse me. It needs to be concentrations and not moles. So our concentration unit is molarity, big M, which is moles over a liter. Do I have the moles? Yep. Do I have the volume? Yes. So it's just going to be 0.05 divided by 1, which is just 0.05. So my HI concentration, moles over liters, 0.05 divided by 1 is just 0.05 molar. But I put this in here because I want you to realize that we're using concentrations and not just moles. So you need to do that math if it's not just nice and pretty with just 1 liter. Okay, so we know we start at 0.05 molar of this guy. Okay, and then do I know anything else about concentrations or anything? Nope, because that's the ones I'm trying to find, and then I just know temperature and Kc. All right, so let's go back. Let's do the other initial. So if I start with HI, am I going to have any H2 or I2? Now this is where you go, well, I thought H2 and I2 were reactants and this was a product. Remember, equilibrium, I could go forward or I could go back. So this is a reverse reaction. I'm going backwards. Okay? So if I'm reversing, I have this that I start with, and then I'm going to have none of that. Okay? Now, if this is where I start, is he going to be, because if I'm doing change, is he going to be negative or positive? One of the hints here is like you have this guy, he's going to make this, so this goes away, these are made. So it's kind of where we have a number. It's kind of a helpful hint. So he's gonna go away, so he's a negative, and I'm gonna make these guys. Now I gotta figure out how many x's. There's a 2 here, so this is a 2x. There's a 1 here, so this is a 1x. There's a 1 here, so this is a 1x. All right, let's do my equilibriums. 0 plus x is x, 0 plus x is x, and then this is 0.05 minus 2x. Very similar to what we did before, okay? But now we have to solve for our x. Before we used an equilibrium, but they didn't give me an equilibrium. The only thing they gave me that I haven't used, because I use this, is temperature and Kc. Remember, the temperature is there because when they tell me Kc, they have to tell me at what temperature, because Kc is temperature dependent. So that temperature doesn't really do anything as far as math goes. So it's the Kc. So they said Kc is equal to 76. Well, let's write out what Kc stands for. Kc stands for my product, Hi squared over H2 times I2. Now, here, this is where, instead of using an equilibrium to solve for x, we're going to use the Kc to solve for x. Okay? So we're going to plug in the Kc, and we're going to plug in each one of these to my concentrations. Okay? So it's going to be 76 is equal to Hi 0.05 minus 2x squared. You plug that into the concentration, x times x. Okay? We're just taking whatever we found in the equilibriums and plugging it in. And then we already know Kc because they gave that to us in the problem. All right, now let's simplify this a little bit. Let's make the bottom look similar to the top in the fact that let's make that a squared also. Now, if you have a squared on the top and a squared on the bottom, this is where the problem is a lot easier than the next problem we're about to do, where it's not squared. Okay? So if I want to get rid of the squareds, what do I do to get rid of the squareds? Yeah, I'm going to square both sides. Okay? So I'm going to square root. Sorry, I said square. To get rid of the squares, I'm going to square root both sides. Square root, square root. All right. So on this side, it was the square root of 76. I'm just copying it over so that you can see what we had. Okay. Square root of 76 is 8.718. Okay. On this side, when we take the square root when there is a variable, then it ends up being plus or minus. So this is going to be plus or minus 0.05 minus 2x divided by x. Because of this square root goes away and this square root, this square and on the top and the square on the bottom go away with the square root. Too many squares in this problem. Squares, square roots. We'll figure it out. All right. So now what we want to do is we can actually separate this out, and we can do with the positive and negative in a second. Let's move over my x. So let's make it 8.718x is equal to plus or minus this guy. As long as we distribute it to 1x, we'll be fine. Okay, so now we need to say, is this going to be a positive symbol or is it going to be a negative? All right, so let's say 8.718x is equal to a positive 0.05 minus 2x, or 8.718x is equal to a negative 0.05 minus 2x. So we need to distribute it out. Let's see. So let's do the positive. So now we've just got 8.718x is equal to 0.05 minus 2x. Let's move the 2x over, so we're going to add it. So 10.718x is equal to 0.05. Divide both sides by 10. And here we get x is equal to 4.67 times 10 to the negative 3. All right, so that's just one side. Let's do the other one. Okay? So here we're going to say 8.718x is equal to negative. So we have to distribute the negative. So negative 0.05. Then we have to distribute the negative to here, so it's a positive 2x. So you have to distribute the negative to everything in the parentheses. All right, move over my 2x, and we get 6.718x is equal to, that looks like I'm moving it there. Let's go into the other side. There we go. It's equal to negative 0.05. All right, now I want to get my x by itself, so I divide the 6.78 over, and I get x is equal to negative 7.44 times 10 to the negative 3. All right, so now we have x. The whole goal was to figure out the equilibrium concentrations of HI, H2, and I2. These equilibrium concentrations. In essence, we want to know this number, and this number. So once we find x, we know one's concentration. Now we have to figure out which x. So for H2, its equilibrium concentration is just x. But I can't have a negative concentration. So since I can't have a negative concentration, that means this one isn't valid. Because I can't have a negative x here. So it means this one is the right one. So let's solve for these. So we said, come on, go to the next slide. There we go. So I'm just going to copy this over. H2 is x, I2 is x, HI is 0.05 minus x. So H2's equilibrium was x, I2's equilibrium was x, HI's equilibrium was 0.05 minus 2x. Okay, so we said it can't be the negative because it can't have a negative concentration, so it's got to be this guy. So if x, so my x was 4.67 times 10 to the negative 3. X was 4.67 times 10 to the negative 3. So that means that H2's equilibrium is that number. That means I2's equilibrium is that number. So I got that one. Now I got that one. Now I got to do HI. He involves a little more work. So to get his answer, I got to do 0.05 minus 2 times x, which is the 4.67 times 10 to the negative 3. So I multiply that by 2, and I get 0.00934. And then when I subtract, I'm going to get HI's equilibrium value to be 0.0407 m. All right, so now we have our answer. Our whole point was to find the equilibrium concentrations, these guys, for HI, for H2, and for I2. And that's what we found. Okay, we found the equilibrium concentrations for each one. Now, you don't have to do this next part, but I recommend it. This is my check. So this is a way to check to see if you did your work right. You did all this math, you powered through this long ice table problem, and you're like, I don't even know if I did it right. All right, we know what Kc was supposed to be, 76. And we know Kc is Hi squared over H2 times I2. So we can plug in these equilibrium values to this and see if I get 76. So I can plug it in. Plug in my HI, plug in my H2, plug in my I2. The top comes out to be 0.00166565. The bottom is 2.18 times 10 to the negative 5. When I do top divided by bottom, I get 76. That's what I get. That's what they gave me. So I didn't mess up anything. So it's just a good way to check your work. On the test, you might not have time to check it, okay? But if you're doing your homework, especially when you're practicing and doing this, I recommend the check. If you have time to check it on the test or a quiz or something like that, then go for it, okay? But all you need to do is we need to find these guys. This was the whole goal. What were my equilibrium concentrations? All right, so that's where we're gonna stop for here. On the next video, we're gonna do another problem. That looks very similar.